Students, we're going to go over some additional samples of what is called, commonly called shortcuts or proofs, triangle shortcuts, congruent triangles and proofs. We're going to do a couple examples of each, both of narrative, a coordinate proof, as well as a formal proof, 2-column, and then a web. Now we start with given, implied, freebies, talk through. Given, implied, freebies, talk through. Gift. Given, implied, freebies, talk it through. So we're going to start with the given. We are told that C is the midpoint of AE, so AE. C is the midpoint. And then we go this way, also of BD. It's a midpoint that going that way as well. And that's all we're given. Okay, what are we trying to prove? We're trying to prove that this triangle ACB is congruent to triangle ECD. So we're trying to get these triangles congruent, and the shortcut, there's 4 of them. Side, 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 angle, side, angle, side, angle, 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 side. So implied, what's implied? It is implied because of that first midpoint that these are equal. I have a pair of sides. It's also implied because of that midpoint that these are equal. I have another pair of sides. So that's implied. Freebies. I know vertical angles are always congruent. I have a pair of angles. So I talk it through. I'm looking for why the triangles are congruent. Well, I have a pair of sides. Then I have a pair of angles. And I have another pair of sides. So I know the triangles are congruent by the shortcut side, angle, side. Talk it through before you attempt to write. So I'm just gonna put this right down the margin. So I'm gonna go side, angle, side, triangles, congruent. So that's my little outline. So I'm going to start with my first piece of information was the fact that it is given C is the midpoint of AE. So it's implied A to C, that's this, and C is congruent to C to E. There's my first pair of congruent sides. All right, not too hard. I'm going to name these angles. You can always add numbers to angles just to make it easier. I'm going to show you how to do that. Okay, also, angle 1 is congruent to angle 2, or you could have used the 3 letters. I'm going to go long, inner, short. Angle ACB is congruent to long, inner, short. Angle ECD. So you can add the numbers or use the letters. That's an example of both. And why are those congruent? Because of, that's supposed to be an F, vertical angles are congruent. Then I can say that C is the midpoint. I'm going this way, BD, because it is given. You could have phrased it with it is given that. It doesn't matter exactly how you phrase it, comma. So, because of that, I know that B to C is congruent to C to D because of the midpoint. So there's your other pair of sides, and this was a pair of angles. So you can see I'm roughly following the shortcut. Side, angle, side. Okay, I have established the what is equal and the y is equal. What and y. So now I can finally hit my target, which is to say my triangles are congruent. So I just use some sort of summary sentence finally. Triangle A, how's it phrased? ACB. It's ACB is congruent to ECD because of the shortcut side, angle, side. What is congruent? Y is congruent every single step. What and why? That's an example of a narrative proof. Now we're going to do an example of a coordinate proof. Now when we're working with a coordinate proof, let's specifically talk about, in this diagram, I have this quadrilateral with these coordinates. Okay, I have L at 0, 0, M at 2, 5, N at 8, 5, and O at 6, 0. I want to prove that the triangle LMN, which is this one, is congruent to this triangle. Now you ask yourself, what can you prove on a coordinate plane? Well, let's see here. I can prove on a coordinate plane, I'm using midpoint, slope, or distance. I can prove using distance. That's going to show opposite sides are congruent. So using the distance equation, I could show that opposite sides are congruent. Using slope, I could show that opposite sides are parallel. Now, why would that be important? And that is because if opposite sides are parallel, I can say armpits of the Z are congruent. So if I were sold, those are red are parallel, I can say 3 and 4 are congruent, or 3 and 2, excuse me. And if I say the blues are parallel, I can say 1 and 4 are congruent. So slope would show opposite sides are parallel. After showing opposite sides are parallel, I could also use, as I mentioned before, armpits of the Z. So there's a couple ways to do this. I'm going to show that The triangles are congruent. I could do the distance equation, 1, 2, 3, 4, and that would give me side, side, and then you get this one down the middle automatically. I could do that one. Or by saying that I have parallel lines, I can do armpits of the Z, armpits of the Z, and that would give me angle, side, angle. I could do that one. Or distance and parallel, side, angle, side. So technically all three of those possibly could work. I'm going to show you how to do that one. Okay, so we have to do the math first. And I'm going to find the slope of MN and the slope of LQ. That's the red ones. And I'm going to find the slope of LM and the slope of N to Q. And you will see why that's helpful in just a moment. Okay, so y minus y over x minus x. Y minus y. X minus x. Y minus y for x minus x. Okay, 5 minus 5 is 0. 0 over anything is just 0. So my slope here is 0, and my slope here is 0. Now I'm going to go this way. Y minus y, this is the blues, so that's 5 minus 0, 2 minus 0. Y minus y, that's 5 and 0, 8 and 6. So my slope here is going to be 5 over 2. My slope here is also going to be 5 over 2. So I've established that I have parallel lines. I'm going to erase all this so you can see. Okay, so I'm trying to show how to get those two triangles equal. Because of those parallel lines, I can do angle, side, angle. So I'm going to go down this way. Angle, side, angle. Let me explain. Okay, I'm going to start with the summary statement. It is given that L is at 0, 0, M is at 2, 5, N is at 8, 5, and Q is at 6, 0. Statement number 1. The slope of MN is 0, and the slope of LQ is 0. So MN is parallel to LQ because slope equals slope. Therefore, so you can go like this because you prove parallel lines. I can now say armpits of the Z are congruent. Therefore, angle 3 is congruent to angle 2 because of alternate interior angles congruent. That gives us a pair of angles. I have a reflexive side here, L to N, so that one's easy. I just write L to N is congruent to L to N because of reflexive property. There's a pair of sides. Next, I can find the slope, S-L-O-P-E, of LM equals 5/2, NQ equals 5/2. So LM is parallel to NQ. Because slope equals slope. Now, because those are parallel, I can go like this and say angles 1 and 4 are congruent. Therefore, angle 1 turn to angle 4 because of alternate interior angles are congruent. That gets me a pair of angles. So it is a hamburger angle, shard angle. Finally, I can say these triangles are equal. All right, LMN, NOL, that's an O this whole time. I've been writing it as Q. Finally, triangle LMN is congruent to triangle NOL. By angle, side, angle. I'm going to show you what's traditionally called a formal proof. A formal proof. So we are given implied freebies talk through. We are given that angle AEB, so AEB, that's basically angle 1, is congruent to ACF. ACF, angle 2. So we have a pair of angles. We're also told that a E to B, which I'm going to trace it here, E to B is congruent to C to F. We want to explain how we know this overlapping triangle AEB is congruent to the overlapping triangle ACF. Now pull these triangles out so it's easy to see. So we have ACF, ACF, that's angle 2. And then we have triangle AEB, and that's angle 1. Okay, so let's recap our given information. We were given that this angle AEB, which is essentially angle 1, and ACF are congruent. So I have a pair of angles. Huh. We're also told that FC is congruent to EB. That would be a pair of sides. So I have a pair of angles, a pair of sides. There's my given and my implied. There's a freebie here. It's a little bit harder to see. Overlap your hands like this. Pull it apart, put it back, pull it apart, put it back. I'm going to do that a couple times. You can see those two triangles overlap and share angle A. They overlap and they share angle A exactly. That's called a reflexive angle. So this is a tail. This is an angle, a congruent angle, and then a side. Angle, angle, side. So this is angle, angle, side. So that shows those triangles congruent. We're going to write this up here on the right-hand side. I'm going to kind of shrink it here so it's easy to see. I'm just going to bring this over for a quick reference. This is called a two-column proof, also known as a traditional proof. So you put the how on the left. I also call that the I know that. Why on the right. We've got how, question mark, why, question mark. So I already know it's going to be angle, angle, side. So I'm going to roughly follow that step. So step number 1, I'm going to go for what are my given angles? And that was angle, this one right here, AEB, angle AEB is congruent to angle ACF, which is the same as angle 1 is congruent to angle 2 in the diagram. Why do I know that's true? It is given. This is a pair of angles. 2. I know that they share that angle A. So I'm just going to say angle A, and it's all by itself. So I can just call it is congruent to angle A. Why do I know that's true? That's called a reflexive angle. There's an angle. Number 3, we were told that EB is congruent to CF. AB was right here on the pullout, and CF. Number 3, why do we know that's true? Because it is given information. Voila. I know these overlapping triangles, AEB and ACF. Are congruent. Why? Because of the shortcut, angle, angle, side. Here's a last example. This is called a web proof. That was a 2-column proof. This is called a web proof. And we're going to use this information given, implied, freebies. I'm going to talk it through. Here we have a diagram. So we are given AC, the segment, bisects BCD. Just going to write the word bisects going that way. Let me color code it for you. So bisects going that way. And CA going this way bisects the angle BAD. Bisects. Okay, I am done with my given. What's implied? Well, of course, because of that bisector, I know that angle 3 and 4 are equal. This is a pair of angles. And because the green's been bisected, it's also another pair of angles. Freebies. AC is reflexive. That is a side. I'm being asked, why is this triangle, BAC, congruent to this triangle, DAC? And the reason why I know these triangles are equal right now is because of the shortcut angle, side, angle. It is a hamburger. Angle, side, angle. I'm going to show you, we're going to do what's called a web proof. So web is the only one that shows how information fits together. How information. So I'm going to go vertically in my web, and I know vaguely that I'm going to go angle, side, angle. So I asked, like, where are the angles and why are they congruent? So we started with the fact that AC, you put the how in the boxes and the why as the connectors. So we were told that AC, the segment, bisects angle BCA. No, BC, what letter is that? Is that D there? BCD, yeah, BCD. And why do we know that's true? Well, that's given. We were also, for our another angle, we were told that CA going this way bisects angle BAD. And why is that true? It is given. Now, what's true because of the bisector? Really simple. I got angles 3 is congruent to angle 4. Right? That's 3 and 4, if I'm not mistaken. Yeah, 3 and 4. And why is that true? That is simply definition of a bisector. Going this way. I know angle 1 is congruent to angle 2. And why is that true? Definition of a bisector. I have a pair of angles, another pair of angles. All right, the side is a freebie. It's not connected to the given at all. So I can just squeeze it in the middle here, and that's the reflexive. AC is congruent to AC. Why is that true? Because it's a reflexive side. So that gives me my S. All 3 of these pieces of information, 1, 2, 3, feeds into the conclusion. That's why web proof is the only one that shows you how things fit together. That will enable us to say that triangle DABAC is congruent to triangle DAC. The reason is angle, side, angle. So web proof is the only one that'll show how things fit together.